over 10 years. They showed how much money they would have made. And then somebody went in and looked at what the model was suggesting. What the model was suggesting is that when the prices are high, you use up lots of cows, and when the prices go down, you turn the leather back into cows. So, and that's an efficiency in the underlying model, where the underlying model is allowing you to do things that just don't make sense. That's not really a part of the optimization structure as such. Okay, so that is indent 1. So what happens to net cash flow is investment changes, investment costs money, pushes it down, and so we kind of find the optimal investment. And I want to show you now how to use a net present value of cash flow. I think that'll work. This time we want to pay off at the end of the simulation because of the net present value. And this model, when the discount rate is 0, is actually the same as the one we just used. Let's open up Invest 1. So exactly the same. The top part here is exactly the same. So the sort of physical production process is the same. The capital part is actually the same. The only difference here now is we have revenues. Everything was up to here is the same. And we have net cash flow. Actually, that's in the same. And then instead of having the cumulative cash flow, we have something called the NPV of cash flow. So how many people here are familiar with the NPV concept? Pretty much everyone. Good. So the NPV of cash flow uses a built-in function called NPV, surprise, surprise. And it just takes as its argument a net cash flow, a discount rate, and I believe the final argument is the initial value of the cash flow. Because NPV cash flow, even though it's being written as a converter here, should probably be rewritten as a delay converter. It actually involves some amount of integration in itself. So we can change that type to a delay converter just to make that known on the diagram. So delay converter is just a converter that is going to be using something that has a stock in it, and it allows you to kind of make a symbol that represents that. It doesn't make any difference to computation, it's just for presentation. So if the discount rate, which I think is 0, of the net cash flow, now this may or may not be obvious, if you do the NPV of cash flow with a discount rate of 0, it is equal to.
Say that again.
If you take the NPV of a cash flow and the discount rate is 0, that is the same as doing what?
Nothing.
Multiplied by 1.
Almost multiplying by 1. It is the same as
Nothing.
That would make it 0. It is not 0. It is the same as just accumulating the cash flow over the course of the simulation, which means it's exactly the same as the previous model we did. So let's just see if that's true. Let's set this model up the same way we did the last one. Let's optimize it, make sure we get 1971, whatever it was. So, payout function. We grab in now, instead of the cumulative cash flow, it's the NPV of cash flow. And we want the final value again, because that's the thing that matters the most. And then in the optimization, we tell it we're going to use that payoff. And for a parameter, we're going to still have investment. And we're going to let it run from 0 to 25,000. And we're going to optimize.
Excuse me, a little faster.
Okay.
Yeah, please, yes.
That panel and we're showing
Yeah.
values.
It's the same thing we did last time.
I said something we didn't last time.
Yes, last time is also faster.
Okay, that is-
Please.
Okay, so there's the panel. This is the payoff.
Payoff.
NPV cash flow, a weight of 1, final value.
Wait a minute.
And then optimization is over investment.
Optimization
And 0
is,
and 25,000.
Yeah, some of us have to scroll to
investment.
those different fields, so we can't go as fast.
Investment and 25.
Just give me a hard time, that's all.
Okay, now we'll start.
Go ahead.
Sorry, I missed the payoff tab.
So the payoff, so it's the NPV of cash flow, and it has a weight of 1.
Thank you.
So with any luck, if we do this, and we click on O run, it will give us a investment of 1979-1163, a payoff of 21182, and I can go back and look at my other model. Invest 0. We'll do O run again because I've lost it. 1979-1165. Payoff is a little bit different because it has a slightly different interpretation, but it doesn't really matter. But invest 1, 1979-116. Okay, you get exactly the same investment. The payoff method, actually the payoff may be exactly the same as well. I think it probably is. Okay, so this is the same thing. So you've got to ask yourselves, or me, this question. If I just did the same thing, why did I do it? Right? More than demonstration. More than demonstration. If we change the discount rate from being 0 to being something higher, what's going to happen to our optimal value of investment? Is it going to go up or is it going to go down? If we make the discount rate fairly large, let's say 15%, so there's a significant discounting of things in the future, what's going to happen to the amount of investment we make?
The investment or the amount of?
The amount we invest.
It's gonna decrease,
Why?
because you're dividing over, you're saying the discount rate is higher?
The discount rate is higher, so money in the future will not be worth as much as money is now.
So there's inflation, right? So
That could be because of inflation, but I'm not
that's generally-
just saying we're gonna not pay as much attention to the future as we're paying to right now. What's gonna happen to the amount that we invest? Okay? Your intuition on this is weak, right? And it should be a little bit weak. This is a fairly abstract problem. If you haven't studied resource economics, it's like, no, you probably don't know the answer to this. That's cool. Let's do it though. Let's go to the discount rate. Let's dial it up to 0.15. If I can do that. Maybe easier to just double click and type in a number. 0.15. Okay. One invalid equation. What did I do? Oh, I forgot that I was in Europe. Ah, that's what I did. All right, 0.15. And now I'm going to do again an O run. And it says the optimization investment is $7,196. Holy camoli kaboog. That's a lot. So I look at the amount of capital. Whoa, it's way up there. Investment, of course, is lines, but it's way up there. Reserves, oh my gosh, what happened? What happened? Reserves, what? Nope, I'm a little confused. Hang on a second. Capital in 4 is really high. Reserves in 4 is really, really low. Where the hell am I? 5. Wait, I'm confused. How did I get a 5th run? Where did this come from? Let's get rid of the 5th run. So there's this thing called the data manager. It will allow me to delete run 5, which I don't understand where it came from. So run 4 was the optimization I just made that gave us this big investment. Reserves then go down really, really fast. And production does what? It goes up and it plummets. And it plummets because we run out of reserves. So if the discount rate is pretty significantly high, what you do is you use up the reserves as fast as you possibly can, because you want to get that production happening as soon as you can, because if it happens in the future, it's not worth much. So it better happen right now so we can get the revenue right now, so we get a net cash flow right now. People who have a high discount rate do what to the future? Sorry, I'll get off my horse. So that's Invest 02.
Can I ask a question?
Yeah.
Isn't there an assumption here that, first of all, we said that the value of money decreases
Yes.
by 15% annually?
Yes.
Which means that to get the same capital that will provide you the same productivity as today, you need to spend more. But this model doesn't reflect that. It reflects that if you add more capital by paying more, this will increase productivity of that.
It will.
Yeah.
So there's nothing, we have 3 parts to this model. We have physics, field production physics. discount rate has no effect on that.
Exactly.
We have
Ah,
physical
right.
capital plant, discount rate has no effect on that.
Of view results.
And then we have
View
net cash
results,
flow.
sorry.
Actually,
Okay.
discount rate doesn't still affect that. Then we have net present value, discount rate affects that. Discount rate affects nothing in this model except this one little bit. All of the physical stuff, there's no impact at all. You invest $1 today, it gets you $1 worth of capital now, which will depreciate over time. You invest $100, you get $100 worth of capital, it will depreciate over time. We are not changing any of the physics of the system. All we are doing is saying, okay, 15% rate, that means that if I get $1 tomorrow, I don't care about it as much as if I get $1 today. So the physics haven't changed at all. That's really important. What has changed is if we were actually using this as the tool by which we were deciding how much to invest, the behavior has changed.
You're
not
saying that
physics.
it's $1 today will do the same work as $1 in 5 years' time, in terms of production.
In terms of production, it would, yes. Because we haven't changed the physics. I can invest $1 today. If I weren't depleting the field, I can invest $1 today and I'd get, say, a gallon of gas a year or something from it. Or I can invest $1 in 5 years. In 5 years, I'd still get a gallon of gas per year from it. Doesn't matter when I invest it. The physics don't change relative to when they're executed, except for the fact that there's a depletion going on. What does change is my interpretation of that. I invest $1 today, I get a gallon of gas per year, and it's worth something. If I invest it in 5 years, I get a gallon of gas per year. It's not
I still have the same problem.
So with the
Because
capital,
you're basically saying that labor costs the same in the future as it does now?
Yeah, you guys are complicating this problem. Complicated. I have a very, very simple world here. All I have is capital, I can invest it or not, and nothing about that world changes if there's a discount rate of 5,000% or 1%. The physical world has not changed. What has changed is our behavior as a consequence of that discount rate. It's a different thing. And labor, capital, blah, 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 none of it matters. The difference here is, do I think something in the future is worth as much as it is now or less than it is now? That changes behavior, it doesn't change physics.
so when we look at capital with so much more accumulated at the end of the 20 years, it may be a bigger number, but it's not necessarily worth.
It's not doing anything at that point, and the cost of making it in the future is pretty low as well. From our sitting here now and looking out in the future, oh, I'm investing so much, who cares? It's all discounted. Doesn't matter. I mean, it's a funny way to look at things, but it is kind of the standard way to look at things. Both funny and standard. But let's go on. There is something else that's wrong. So, I mean, I was just trying to show you that as you change the discount rate, it really affects the optimal result that you get. And we did it in a very dramatic way. 0 to 15% is obviously a very big change. But you can see what it does is it shifts. The higher the discount rate, the more things shift towards the present and away from the future.
And we don't have to worry about that buy flow because it's only an inflow anyhow, so it would have no impact changing. the
Oh,
buy flow.
yeah, it
And
should.
The stock would never go negative in this example, so we don't need to worry about being a negative stock. So that shouldn't change. If we made those changes, we should have the
All right,
exact same.
we should make those changes and make sure that what you're saying is true. And thank you for pointing it out because I was getting careless. So let's go to this thing and make it not non-negative. Let's go to this thing and make it a buy flow. Well, no, we're in capital. Sorry. So that problem was down in the net present value of cash flow. This thing is by nature only a flow in, and this thing is depreciation. So it really doesn't make any difference for this one. The physical part, we didn't have a mistake. It was actually in the accounting part that the mistake occurred before. Okay, so there's something else wrong with this. Besides, so we kind of learned a little bit about what happens to the discount rate shift in terms of shifting production, and I'm on a different thing right now. But what else is funny about the way we're running a business here? Now put your business hat on, since I've taken, take your green hat off and put on your business hat. What's wrong about the way we're running our business here?
Should you be investing more as you're earning more, or should there be a link between those?
Okay. You keep complicating this problem. It's not that you're complicating it. So this is like, we call it micro world sometimes. It's a simplified view onto the world. And you're projecting onto it things in the real world. that aren't contained in this piece of the universe that I'm presenting here. And so they're not wrong, but they're not kind of part of this modeling framework that I'm using. So really all we have here is some investment and some capital. But what I'm saying is I'm going to invest a certain amount and I'm just going to keep investing it forever. If you're running a real business, what would you do?
Manage your rights.
You do. Invest for a while and then you say, okay, I'm happy. And then you stop investing because there's no point investing anymore because you're getting no production from it. So you kind of vary over time the amount that you were investing. So what we'd like to do is instead of having investment be a constant thing, we'd like to have investment being changing over time. And that, I believe, is invest 03, or invest 3.
So it doesn't matter, because you have net cash flow, before you go to invest 03, you have net cash flow, but it's just accumulating revenue and investment, it's not really net because there's no expenses included.
No, investment is an expense.
Okay.
And this is a revenue is income. So this
And
is
that's the
income and
only
expense.
expense you're
And then that cash flow is then the net of those two. And the net present value is properly formulated.
And by the way, I got different results by flowing and going down there. And I like to have that simulation on. And 7196, the difference is over, and 1399 instead of 1404. The value is 138.
Oh, because you started at a different location. So it's just tuning in and so if you run this, if you optimize more than once on these models, we just run the optimization again on this. No changes. So the first time it said 86 runs, investment 719614, and that said 138 runs, investment 719613. You can see the payoff is just a tiny little bit bigger. Actually, it's exactly the same, but it's a tiny little bigger. The decimals that aren't showing. And what happens is if you start with the Powell optimization, if you start it again, it starts from where it left off, and then it will try and refine its thing, and it typically it doesn't change much anything. It changes it in kind of far away decimal points and doesn't have much effect. Typically it's at a pretty converged point, but
So
the
it just
second
keeps
time,
adding on to the
yeah,
runs.
it'll just, it'll kind of wander around. It'll never get anything worse, but it won't necessarily get any better either.
Well, my next one went down on my number of runs, but move on.
The number of runs will go around. It's a convergence criteria. Yep.
If I run another optimization using Powell, it will start where I left off last time.
Yes.
But between the two simulation runs, I changed some structure. Will it also start at the same point it was at?
Well, to the extent that the structure you changed didn't affect the parameters that it had found before. So if you changed one of the equations, one of those, it'll reset that equation. But if you left all that alone and just changed the structure, it will still start with those set of parameters. Now then it will likely, since you changed the structure, go to a very different set of parameters. And the payoff will not probably be the same as it was the last time you ran it for those parameters. So I'm going to open up Invest 3. And Invest 3 now has, the oil field production part is identical. Well, not quite. I put in a little bit more stuff. So in the early ones, it didn't do this much. But if you think about what's happening when we're allowing it to vary over time, what happens if you invest like an amazing amount of stuff in day one, and then just throw it all away in day two and get some salvage value for it, because there's a salvage process in this thing? You would get, when the structure we had before, you'd get an amazing amount of production, and then it would go away. But if you actually have an oil field and you drill a well that's like as wide as this room, what do you get? You get a well as oil pipeline as wide as the room, but you're not going to get oil out of it at that kind of a rate. Well, actually, if you drill the hole, but anyway. If you invest a lot more reasonably, you're not going to get that kind of an increase in production because there's going to be caps on how much you can actually pull out. Actually, okay, let's go to physics. Who knows about limestone and stuff? Good, I can say anything I want. So you drill a well as big as this room, you go all the way down. What you've got in the bottom of the well is a pool of oil. You can immediately pull it out. But that pool of oil is a small fraction of the amount of oil that's in that field. Because most of the oil in that field is dissolved under high pressure in limestone, and it will seep in towards the well hole. And so you'll immediately pull it out, it'll be dry, and then you'll have this stuff seeping in, and you'll only be able to pull that out as fast as it seeps in. So the physics of the production process says there's just some maximum rate you can pull stuff out, and you're going to be that's going to be managed by the physics of the thing. So there's this maximum production rate. So we've gotten a little bit more sophisticated in the representation of physics, which is necessitated because of the fact we're allowing people to put like ridiculously large amounts of capital in if they want during the optimization process. And then there's some extra structure in here to get investment from this investment by time concept, which is really, why is revenue going into, because I can't read my labels. So investment by time, let's start there because it's kind of the easiest. Now, we didn't get very far in arrays this morning, but this uses some weird array stuff. So investment by time is an arrayed variable, which is shown by the fact that, let me zoom in a bit. It's shown by the fact that it's drawn as three things underneath one another. So it's arrayed, if we go to the array panel on, it's arrayed by time period. And if we go and look at the array editor, there are 20 different time periods. Each corresponds to a year of the simulation. And so what this is doing is it's saying there are 20 different values of investment, some value for year 1, some value for year 2, and right now they're all just at 10,000, but if you hover over something like this, you have to click off and hover. There, if you hover over something like this, it will give you the value for each of the elements in the array. There are 20 of them and they're all at 10,000 right now. So what I do is I want that to apply to a time period. So I set up this really, really funny variable called isThisTimePeriod. And isThisTimePeriod has a really funny equation called if int of time is equal to the time period minus 1, then it's 1, otherwise it's 0. And so this is just going in and selecting first for a while, then the second for a while, then for a year actually, then the third for a year, and then the fourth for a year. You have a question, or are you just?
Why are we using arrays for investment by time and not plots?
And not which?
The plots function, because it's an investment that we're plotting every now and then.
No, what we're doing is we're investing at a continuous rate over the course of a year, and then investing at another continuous rate. We could do the investment as kind of we could do it with a pulse function, saying you're just investing for that year at a particular time, not spread out over the year.
Yeah.
Wouldn't actually make very much difference to the results. A little bit more complicated to set up.
Okay.
But it would be a perfectly reasonable way to do it. So isThisTimePeriod simply switches between the elements of investment by time. So the first one only matters for the first year, the second one only matters for the second year, and so on. So investment then just becomes the sum across these guys of the investment by time multiplied by this funny thing called isThisTimePeriod. And actually, I can just run this so you can see what isThisTimePeriod does. This is a little bit weird. There are a couple other ways you can do this. So isThisTimePeriod for T1 is this. Then T2 is that, T3 is that, T4, T5, T6. And I'm going through all the different subscript elements. You can see what happens is the first one starts at 1 and then drops to 0. And the second one picks up where the first one left off. In fact, if I were to do this in a graph, it might be easier to see. It might be harder to see. You can ask to just show everything. I think maybe it's harder to see. You can see the first one is up and down, and the second one is up and down. But the thing that you can see about this is at all times, there's one of these that is a value of 1. So it is switching between the different array elements. And so what investment is now doing is it's summing up all of these different array elements and figuring out, it's using the one that's appropriate to the time it's got. All right, so if we want to optimize this, it's exactly the same process, except now we're going to have 20 things we're optimizing over instead of 1. So we go here, we go to the optimization panel, we pick up payoff, which will again be the net present value of cash flow. it's gonna have a weight of 1, final value is what we care about. In the optimization, we're gonna go to an optimization to the payoff. I'm gonna select the investment by time, and I'm gonna ask for a star, which means it's gonna do all of the elements of investment by time as part of the optimization, and I'm gonna go between 0 and 100,000, which is a bigger number, because we're allowed to invest more if we want. That goes between 0 and 250,000, or 1 million. Why don't I start shit? And now when I optimize it, it's gonna take a lot longer. These are funny things. You can see over here it's doing its optimization, and then it's changing its payoff, and it's made 4,000 runs so far, so it makes about 5,000 runs. It finds this set of values, and it's kind of the easiest way to look at this result, probably to just get a graph of investment. And you can see what we had before. We actually get rid of run 1. It's not confusing things. What happens is you invest a lot up front, then it goes to 0, then you invest a little bit more, and it kind of banks down. You invest a little bit more, goes down a little bit, up a little bit, down a little bit, and towards 0. And kind of the interesting thing to watch here is the amount of capital, because it has a fairly interesting pattern. So what happens to capital is it jumps up because you're doing this investment, and it goes down a little bit because you stopped investing, and then it's kind of held at a plateau level for a while. And then the investment stops and it basically depreciates over time. So you front end the investment, which isn't a big surprise, and then you kind of maintain the amount of capital, so for depreciation investment almost for a while, and then you let the amount of capital diminish. So what do you think happens here if you increase the discount rate? Now we have good intuition for it. The discount rate is, I don't actually look. So discount rate is 3%, yes. So if we were to increase the discount rate to 15%, what would happen to investment? You'd expect it to kind of move forward in time. We can do that fairly quickly. Just winding this up a bit. Around 15%, running it, and then just comparing. I don't know, let's take the finish here.
So on this previous run, while it's doing there, the message that after 4682 runs, the best value of payoff is that amount based on a value of this at T1, a value of that at T2.
Yes,
a value
those
of
are all the different things that are in. All the different components. And now finished, and if we look at investment, we can see that it invests a bit more upfront, not so much change here. And the reason the change is much smaller is we were already kind of investing almost as much as we could upfront. And the reason it happens that way is the biggest productivity of this field occurs when the field has not been depleted at all. So there's just a lot of incentive to invest it right away, right at the time that the field has the biggest ability to produce stuff. So that the difference in outcome is not as substantial as it was in the full-on investment case. All right, so we have like 9 minutes left. What I want to do, yes?
Just a quick question. If you want to make a finer scale than a year, is it just a matter of requiring more computation time to get an optimized investment?
Yes. 20 is actually a pretty big number of parameters to be optimizing over, so if you were to go to a bigger number. So typically, if you were actually being thoughtful about this, you'd say, well, I know it's going to kind of follow this pattern. So I'm going to go very fine scale for the first year, and then I'm going to go rougher scale for later years, and maybe not doing any for even later years. Yeah, but it's just a matter of writing out that kind of combination.
Oh,
of things.
I
Yes.
have a very important question. Actually, because I believe this class year would start at 14 and start at 13, so I arrived late. My question is following. Do these case studies exist written somewhere so that you can download it, or in a book you can follow it step by step? Because I entered here in the half of the class, so.
Right. So there is a pretty nice optimization tutorial in the health manuals, on the online health.
Okay.
So if you go to.
So the answer is that there are tutorial, but there are no guided case studies that I can.
Not case studies as such, but it kind of walks you through the issues. There is a webinar on optimization.
I'm not asking to only refer to Stella. Did somewhere, I'm asking also the whole class.
So there is a handbook of analytic techniques for system dynamics, whose name I keep forgetting, that has some chapters in optimization in it. So it's got some chapters of some more, even more esoteric, lots of chapters are more esoteric things actually. So that's one resource, but there isn't that much written up on this kind of optimization stuff in terms of case studies that I know of.
Okay.
Yes?
This will sound funny, but what's the difference between Stella and Stella Architects? What can I do with Stella?
So
which I cannot do with
Stella is the family of software, and we have two kind of main products. One is called Stella Professional, which is really what we've been working with today. And then the other one is called Stella Architect, which combines this with the ability to create interfaces for your models. And the next session will be all about the interface side of Stella. So we'll use the interface side of Stella Architect. So, and then we also have Stella Online, which is an online version of this kind of stuff, but it does not have optimization capabilities. Does that make it clear? And there's also, I think, but you want to pretend you forgot that name. Because it's really the same thing as Stella.
I did not get which is the most complex and which is the simpler one. The
Stella Professional only does the model layer. So you can only do modeling with Stella Professional. Stella Architect adds in the ability to create interfaces. So Stella Professional plus the ability to create interfaces.
In Architect, you do everything.
We actually have a thing that only does interfaces, but it's not really interesting to most people. Okay. Yes. I'm happy to share the slides from this session if you give me a card, or actually better yet, I give you a card and you send me an email in about a week or two. So come up and grab a card from me at the end of the workshop. I was trying to get to sensitivity combined with optimization. We don't have time to make you work through it, but let me kind of walk you through the conceptual way that it works. Okay, so sensitivity of optimization. No, this is not full-on sensitivity. So we've been looking at optimizing effectively over a single run, but that might not make the results robust, and so you might want to see a range of behavior. Actually, I'm just going to show you an example of this. I think that'll be the most fun way to see it. So let me open up. You don't need to do this. I'm going to open up a model on here called Licency, and it's called Fishing 01, I believe. Hopefully it's got stuff set up. Yeah, so let me try Fishing 02. Okay, so this has O run and S run. So this is a little fish depletion thing where you catch based upon effort-based fishing, you get a catch. And the sensitivity on this thing says, how many people are familiar with fish tanks? Yeah, so it's a simplified version of that kind of a model, really. It's quite simple. And if we look at this thing for the optimization, so payoff is obvious. It's just the amount of catching you can do over the course of the entire. This one's set up for the final value of catching. It doesn't make that much difference heuristic for this case. And we're optimizing over days fishing, and then we're doing sensitivity over the initial fish stock, because we don't know how much stuff there's in there. If you have a small initial fish stock and you work hard at catching it, what happens to your fish population? It goes away. If you have a big initial fish stock and you catch it pretty hard, that's okay, probably. So if I optimize this thing, what it's going to do is it's going to run a sensitivity on the number of, it should run, I think this is what I set up to do, it's going to run a sensitivity on the initial fish stock and then try and find a value of catching that maximizes that. And you can see what happens. This is now a sensitivity graph that's showing the different runs for the different values of initial fish stock. And what happens here? So when you start with a low fish stock, you deplete the fish population entirely. When you start with a high fish stock, the fish can regenerate themselves, they go to a very high one. If you start with a really high one, they come down, and they all kind of go to this thing. So there are two steady state convergent things, one in which there are no fish, and one in which there are like 1,700 fish or so. And the most interesting thing is which line? It's this one right here. And what the optimizer does is it says, well, I'm going to have to just give up on these two guys because they're not worth it. It's more valuable for me to get all of these guys up to the biggest number I can. And I'm going to catch it just so that this guy, instead of being one of these two, is one of these. So the catch is such that if you were to increase it just a tiny little bit, so if you were to go on the days fishing, which is a 37, and just bring it up a little bit. Oops, I brought it down. Oh, it's not a little bit, it's just very sensitive. 37, I want to go 38 maybe. 30, oh gosh.
Right-click, view results. You can type in another.
I don't know why this one's so sensitive. Okay, so we'll make it 38. And what happens to now the number of fish? That's run 11 we just made. I can't really see it. We bring it up in the results panel, which is here. The fish stock. So run 11.
If you want that to not be comparative, you can go to your page 7.
I want it to be comparative. So we can see that run 11 now is pretty much 0 everywhere. I mean, you can see it in the graph, but there's too many colors, you can't see it all. But basically, we've now depleted it. So in run 10, the fish stock run 10 was one of the high ones. We've now rerun it with what would have been okay, and it's gone to crap. So it's right, it puts that run, I didn't do that experiment quite right, but what I'm telling you is the truth. This particular run, which went along and went up, now becomes one of these runs, and it just collapses. So it finds an optimum where one of the fish stocks which would have resulted in kind of a constant followed by a adjustment towards that, ends up being a collapse. So it's a funny kind of thing. We're optimizing to be a bit more robust, but the solution it finds is, in a sense, intrinsically not robust, intrinsically on the edge of doing things. Okay. I hope that was interesting. So that's optimization in a nutshell. As I say, there are some other things you can do with it. If you send me an email, grab my card and send me an email, I will send you the slides that I used and was going to use for this presentation. And you can experiment with it. And there is a webinar on our website that covers the optimization stuff. It goes a little faster than this. But you're not expected to follow along, so it's not a big deal. And there's also a webinar that Kareem Shockley did that does the differential evolution stuff, which is a slightly different approach to doing optimization. All right?